Alright, so today we'll be talking about areas of parallelograms, including rectangles and squares, okay, and then triangles as well. Okay, so some really cool stuff to work with. But first, we just need to get through the rectangle. Now, rectangle should be pretty simple, straightforward, you guys. Area of a rectangle, and I'm going to leave some space, is just going to be the length times width or base times height. Okay, so here's our simple rectangle. You can call this base or length. It's up to you. And then this would be either height or width. It's up to you how you want to call it. So the area is definitely going to be equal to those two multiplied by each other. So length times width or base times height. Pretty simple. Okay. Just need to put in my time signs right there. Okay, now if we were to go ahead and slant this a little bit and draw us a parallelogram, okay, it might look like, oh my gosh, do we need a whole nother formula to work with? Actually, no, you don't. Okay, so parallelogram area is definitely still going to be the same, except it's going to be base times the height. Okay. Alright, now, some of you guys are probably going, whoa, 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 whoa. How do we know that it's going to be the same type of thing? Okay. Alright, height is usually represented right here, base up here. So height. Okay, so something pretty simple. Now, if I take that same exact shape, this triangle over here, and let's say I lopped it off. Okay. Okay, so let's say I lopped it off, and then I put it over here. Well, guess what? If I put it over here, I know that those are parallel. I know that that's the same length, so guess what? We are dealing with a rectangle. So that's why base times height also represents the area of a parallelogram. Okay? Just remember the height is going to be represented right here. Now the height is also going to be the altitude of the parallelogram. Alright? So altitude, pretty simple. Okay? Some pretty easy stuff right there. Now the base, it doesn't matter which one you use. This could be the top one could be the base, this bottom one could be the base. It's totally up to you how you want to have it actually happen. Okay. Now altitude you could also draw in a different direction. Okay, you could have an altitude be right here, or you can have an altitude be right out here. Okay. The cool thing is they still pretty much are the same. Okay, now let's move on. Let's not dilly-dally anymore. Let's go into the main thing. Okay, let's draw a triangle. Okay, and find the area of this. Alright, now the area is 1/2 times base times height. Now some of you guys are probably going, oh, I already know this and I already know where this came from. Well, as for the rest of us, we are going to discern what's going on with it. Okay. Alright, so triangle, real fast. If you notice, the area is pretty easy. It's very similar to what we've had before. So 1/2 times base times height. Okay? It's basically like half of what this area is and what this area is. That's not just a coincidence. That actually is true because of this reason. Okay. If I were to able to do some kind of, well, let's get rid of that. That's an ugly one. If we're able to replicate the same object, the same triangle, and flip it about the origin, we would get a parallelogram. And once again, if we're able to get a parallelogram, we can cut off this piece over here and draw it up over here, and we could have a rectangle. But since we're only dealing with this part right here, this shape right here, that's half of the entire shape, so that's why we have the half. It's actually really cool how you can actually decompose a rectangle down into a triangle. Alright, now if you were dealing with an actual rectangle and you were trying to go to find the two triangle areas, once again, find the area of the actual rectangle and just do half, and just realize that either you're cutting it from half to here or from half to here. Okay, looks kind of like the Scottish flag. All right, now let's say we actually wanted to find the height. Let's say that we were building a building frame and this was 12 feet and this right here was 17 feet. Let's add a T at the end. There we go. Okay, and you knew one of the well, you know this actual length to the top of the actual building, that this is actually going to be about, I would say probably 15 feet. Okay. And you're just building the frame of the beginning of a house. Okay. Now, if you wanted to find the actual square footage that this was taking up, let's say just total square footage right there, you couldn't find the area of the shape alone. So what you need to do is you need to break it up, this irregular shape, into two shapes you do know. Okay. Now, since you know this bottom is a square, this is definitely going to be the same as that. Okay. And this side is definitely going to be the same as this side. Okay. So now I'm dealing with a rectangle on the bottom and a triangle on the top. And so what I do is I just take the two areas. So the area of the triangle plus the area of the rectangle should equal total area. Okay. Alright, so the area of the triangle is definitely going to be, and you can use 0.5 if you want. 0.5 times 17 times 15 plus, and then the area of the rectangle is going to be 12 times 17, and that should be the total. Okay, when you're punching this into your calculator, please understand that sometimes you're going to get some nasty looking decimals and stuff, and that just don't let it ruin your day. It's just totally cool how it works. And there we go. 331.5 square feet. Now, since we are dealing with units, especially in area, we need to remember to have the square units, square feet, square centimeters, whatever square footage you're dealing with, okay? But just put a square on it. You could actually put this as a representation of feet squared. It's totally up to you. And that totally makes sense because this is a foot and this is a foot, and 2 feet times each other is actually going to get a square foot, okay? Alright, so if you're ever wondering like, why are my numbers screwing up? Go back and look at the units and see if you're multiplying everything. Because these two should get you a square foot. These two should get you a square foot. When you add square feet, those are the same units, so therefore we should be getting square footage, okay? Alright, and that's it for dealing with areas of parallelograms and triangles. I'll talk to you later.